Here is a tutorial on how to make your very own Cracktro. This is my very first assembly coding project, and I'm a total beginner, but I did manage to create a working Cracktro. The code you will see is likely to be crude, and there are probably better ways of doing things, but it works. Let's look at the video assets. Fitting them into the Commodore 64's 64 kilobytes was a challenge. The assets don't fit into the default VIC Bank 0, since the VIC chip sees 1000 to 2000 filled with a backup of character ROM. We can't overwrite it, and therefore the video assets can't fit into the default VIC bank. You can see in this picture that the red area is the part that is occupied by the character ROM image. In VIC Bank 0, there simply isn't enough space for the 27 sprites, screen memory, bouncing logo, bitmap data, and color data. We set VIC Bank 1 by writing a value of 2 to register D1000. What we do need is to be careful that we set bit 3 in register D018 to 1 for the bitmap, the B stored at 6000 to 8000, since the default would be 4000 to 6000. Since we only need the bottom half of the bitmap, and since memory is so scarce, we overwrite the top half of the bitmap with the custom character set for the bouncing logo. This custom character set overwrites 6000 to 68EF. The sprite scroller works by reading a text string that contains the message, calculating the correct sprite pointer value for the text character about to scroll onto the screen, and then updating the sprite pointer. The sprite data is stored at 5000, which is 1000 from the start of VIC Bank 1. The sprite pointers are indexed from the start of the VIC bank. The scroller routine works as follows. The program gets the character code for the letter about to scroll onto the screen from the right. It then subtracts 1 and multiplies by 64 to find the correct chunk of sprite data. Then we add the 1000 offset from the start of the VIC bank. This is 4096 in decimal. We divide by 64 at the end because the sprite pointer system accepts the location of the sprite data divided by 64. Don't ask me why. It's just how it works, so we roll with it. As you can see from the picture, this simplifies to merely adding 63 to the retrieved character code. We will see this in the code when we examine it. You can see that register D010 is loaded. This contains the most significant bits for the 8 sprites. Since the screen is 320 pixels wide and an 8-bit number only goes up to 256, this register contains the bits that handle this extra distance. We then clean out all the bits except for the bit corresponding to sprite 0. We then compare the value against 0, and if it is 0, this means the sprite is in the left-hand side of the screen. We then branch if equal down to the third exclamation mark. This then tests the D1000 register to see whether the sprite has hit the left-hand side of the screen. If it hasn't, we branch down 4 exclamation marks and decrease the D1000 register, thus moving the sprite left 1 pixel. If the value in D1000 was 0, we hit the left side of the screen. The code then sets D1010 to 1, moving the sprite to the right-hand side of the screen and updates the sprite pointers. Note the command that adds 63 to the value in the accumulator. We mentioned earlier that this is what updates the sprite pointers. The bouncing logo was harder to code. The basics are this. A custom character set was created using CharacterPad. I'm no graphic artist, and my logo was pretty basic. This custom character set had to be loaded into memory at 6000. The actual logo data was stored at 4000. 2 screens were used, one at 4400 and the other at 4C1000. The idea is while the screen is set at 4400, scroll left 1 pixel, copy 2 rows of the logo from 4000 into 4C1000, scroll left another pixel, copy the next 2 rows, and so on. Once the scroll register has hit 7, switch to screen 4C1000 and you see the logo offset by 8 pixels from its original position, thus making the scrolling nice and smooth. An algorithm had to be developed that maps part of the logo to the next screen. The part of the screen that is empty is padded out with the empty character, the spacebar. You can see in this picture, for example, that if the logo is half off the screen on the right, that logo data needs to be copied from 4000 into 4414. The offset here is 14 and varies constantly and was harder to code than a sprite scroller. Understandably, there were quite a lot of bugs that had to be fixed during this part of development. You wouldn't think that it would matter much whether a store command was entirely enclosed by brackets or had a Y hanging off the end outside, but I can assure you, it matters a lot. Pages of scrawled notes were produced, but still the bugs kept coming, but it seems that patience is a must when coding. Numerous breakpoints were used to try and work out where things were failing. Some bugs were insidious and hard to spot. There is a bug in this code which is very obvious when you know it's there, but trying to spot it amongst hundreds of lines of code took a while. It's an infinite loop, by the way, and freezes the program. You wouldn't believe the chaos caused by accidentally typing FE instead of FC. Annoyingly, simple commands refused to work for me. Probably because I'm a total beginner at all this. This simple store command failed to function properly, and I had to resort to researching a multiplication routine that someone else coded, and then piecing together the low and high bytes of the address I wanted, store it in the 0 page, and use 0 page addressing. This was a lot more complicated. Compare the code you see here with the original couple of lines. I got there eventually, and you can see the finished product here. The only thing I am unhappy with is a bug that creates a rectangle of corruption within the bitmap. It seems to appear when I use 0 page addressing to store the logo data and use D016 scrolling registers. It disappears when one or the other is disabled. I'm too much of a noob to fix it, therefore it's finished. The Cracktro is entirely my own work. The only bits I can attribute to someone else is the multiplication routine and the music from the game Armalite. I would like to thank Bacchus from Fairlight, who kindly gave me some coding tips, as you can see here. He also praised my code as very complex code for a beginner, or maybe he meant that it's a mess and trying to make sense of it was hard.